Sorry for the interruption. Sorry for the interruption. We again continue the session with the same stream. Due to the network and availability, this happened. Okay, we was on the stage discussing the problem of transmission of AC power, especially from long distances, can be overcome by DC transmission. So the AC transmission are full of overload, full of full of losses, and other kind of eddy current losses, hysteresis losses, skin effect, corona effect, and the kind of these losses out there, frequency oriented losses. But if we moving towards the AC transmission line conventionally to the DC transmission line, that particular DC transmission would be lossless line. And in lossless line, there is no kind of frequency oriented loss out there, because in DC there is no concept of frequency in DC transmission line. That's the reason is world is moving towards on DC transmission line conventionally instead of AC transmission line. And in major kind of ongoing projects in Pakistan as well, it also install the DC transmission lines. I already discussed the concept of DC transmission line in my previous session as well. In Mityari to Lahore, another transmission line also be out there in Pakistan. It also already installed. The first 20 megawatt 100 kilovolt HVDC link in the world has built in 1954 between the mainland of Sweden and Iceland of Gotland. At present, the biggest HVDC link, it has the reaches 6,300 megawatt of capacity and 300 kV of bipolar transmission HVDC line. What is the meaning of bipolar? Bipolar means uh, in power of line, two cable of line, the whole 330 megawatt capacity positive to negative line is being through with the voltage rating of 300 kV as positive and negative. That's the concept of bipolar. Because what why is bi? Because there are only two polarity out there, that is the positive and negative. The top view of a 400 kV HVDC substation is given and below. These are the substation in which the transportation of electricity, junction, suspension, insulator, converter, CTs, PTs, surge arrestor, lightning arrestor, how you can imagine a substation look like. This is the way that how it looks like a substation of 400 kV HVDC transmission line as per the picture from top view. A DC link is the DC power transmission network which consists of transformers, converters, converter units, and conductors. The classification of HVDC system depends upon the arrangements of the pole and the earth return. So this is the concept. They are as follows: monopolar link, bipolar link, and homopolar link. These are the three concepts of link in HVDC transmission line of system arrangements. So HVDC transmission system, further monopolar link are expressed as in below mentioned diagram. A monopolar link has only one conductor. You can see one conductor in transmission with ground or C as a return path. So this one is the return path. Generally, the conductor has a negative polarity with respect to the earth, which we can see in this figure, the in monopolar link. So how DC comes? This is the main concept that we need to understand by the converters, AC to DC and DC to AC inverters. So typically we have HVAC systems, AC systems of electricity, which can transmit electricity in low voltage to step up by the step up transformer. Because there is no concept of DC transformer conventionally, and you can see commercially now these days the concept of DC transformer is not out there. uh, Many of the student has been discussed the concept of HVDC transformer that Siemens introduced in previous years, the HVDC transmission or HVDC transformer, but it is too much costly, not affordable, and it have limited kind of limitations. So practically it is not possible to install a single transformer in HVDC in many of the areas, but the concept of HVDC transmission at HVDC transformer out there. So Siemens already introduced HVDC transformer in market in a couple of years. So what happened? How convert to AC to DC? First, we have a link of AC generator which produce electricity. We need to step up that voltage by a transformer in high voltages from lower to high voltages. When voltage is higher, then we need to transform from AC to DC by a rectifier. So at this level, at this moment, we need a HVAC kind of rectifier to convert that voltage from lower to higher and three phase trans three phase rectifier should be out there to convert that particular AC voltage level to DC voltage level, and then provided the negative concept of polarity, this side of it should be ground and this side should be ground out there, and provide the supply in the reverse polarity of supply, the reverse current you can say. And when transportation would be happened, this concept of transmission we can say HVDC transmission. So we already discussed the conductor has a negative polarity with respect to the earth, because positive we need to earth, and in negative conductor we need to provide a supply, I mean from this side to this side. This is the ongoing and reverse current phenomena by completion of current would be out there. This is a concept of monopolar link in HVDC transmission line. So this conductor we can say this is the HVDC transmission. In a single conductor we can transmit electricity in HVDC, and another conductor is we need to ground from this side and from this side to transport that electricity in a single conductor. You can see that monopolar link has only one conductor with ground or C as written path. So at the end, when DC transmission and ends, we can invert the particular HVDC transmission line of HVDC transmission voltage to HVAC from DC to AC. So this block we called an inverter. By inverter, the DC voltage convert to AC voltage. After AC voltage, we need to step down the particular voltage level from step down transformer. That would be the substation, grid station, or we can say a distributing station transformer, which can step down the voltage. But first you need to convert that DC voltage into AC by an inverter. And after inverter, the voltage would become to HVAC. After that, when we got AC current, AC voltage, then a transformer should be out there which can step down. This is the primary side and this one is the secondary side. Primary number of conductor coil would be higher and secondary would be in lower. So voltage should be step down, but current would be step up. Power ratio remains same, frequency ratio should be out there, should be same. At the end, there is a AC link which can got the AC current from this side. So this is the whole scenario how the AC transmission we can transport by the monopolar link in HVAC to HVDC and then again HVAC transmission system. So up till now, any one of you if I have any kind of question, query, difficulty, please feel free to discuss. I will answer the kind of question and resolve your queries if you have any kind of difficulty. You may ask. Now further we moving towards the HVDC transmission system, which is the second category of bipolar link. So in bipolar links have two conductors, one at a positive potential and the other at a negative same magnitude. So there is a two conductor we need to use, the upper side and the lower side. One at a positive potential, you can see it's a direction positively, and other at the negative potential, you can see in the reverse direction, return current, return path. Same magnitude means the same amount of current voltage which is flow from this conductor, same is in return path or completion of circuit conductor is out there, positive and negative as well. Further, with the respective of ground as well. At each terminal, two identical sets of converters are connected in series. Two identical converters. You can see these two converters are in series, and their central part should be ground in both the sides. So the series rectifier or converter should be out there. So these two set of converters is ground at both ends as shown in figure. Normally both conductors operate at equal potential, so the current through the zero, so current through the ground is zero. So typically if current is flow something from a ground or reach something current to the ground, that means there is a fault out there. So in bipolar link of HVDC of transmission line, we need to discuss here. First, we need a link of HVAC system of power system got by this single bus bar, and then lower voltage should be step up by the transformer from this to this side, from primary to secondary. A step up transformer should be out there to step up the voltages. So lower voltage to higher voltage, lower voltage to higher voltage. So there are two of the bipolar links should be out there, and two converters of rectifier should be out there in series. Same as scenario in the reverse side, two converters series should be out there, and the central part should be ground in both the converters. So transmission line in positive side and negative reverse current, negative completion of current, negative side and positive drive transportation of electricity should be fulfilled by this scenario. And when the whole transmission of HP went done, then that particular DC current voltage should be converted by this inverter, which is in bipolar link. By the converter, we can step down the transformer should be out there. So this is these two are the step up transformer, and these two are the step down transformers, which step down the voltage from higher to lower potential. When step down the voltage, current automatically would be high because we need to maintain the power ratio, power level. Transformer can change the voltage current ratio, but power should be remain same at primary side, also at secondary side. This is the scenario of a transformer. After that step down transformer, both are connected into a single bus, and then we got the step down voltage and step up in current in AC system, which is out there. So this is the concept of bipolar link in HVDC transmission system. Up till now, any one of you if have any kind of question, query or difficulty, then discuss. I will answer the kind of question, resolve your queries if you have in your mind. Okay, further moving towards the third category of HVDC transmission system, homopolar link. Homopolar link has two or more conductors. Two or more conductors should be connected out there, all having the same polarity. All having the same polarity.
Sir, bipolar,
monopolar, or homopolar. These are
sir,
the
same है कुछ.
Yes. What's the question?
सर इनका फंक्शन सेम ही है एक तरीके से देखा जाए तो.
इन दोनों में अगर आप देखें, दोनों सीरीज में लगे हुए लेकिन रिवर्स ऑर्डर में नहीं है. दोनों सीरीज में लगे हुए लेकिन रिवर्स ऑर्डर में नहीं है. ठीक है, पॉजिटिव डायरेक्शन में है और ये नेगेटिव डायरेक्शन में है, और ये रेक्टिफायर है और ये इन्वर्टर है. ठीक है, लेकिन अगर आप यहाँ देखें तो इनकी डायरेक्शन अपोजिट है. ये रेक्टिफायर तो दोनों है, लेकिन एक
ओ,
पॉजिटिव डायरेक्शन में और एक नेगेटिव डायरेक्शन में।
और नेगेटिव डायरेक्शन में।
इन्वर्टर दोनों है, और एक पॉजिटिव में है और एक नेगेटिव में है, तो ये दोनों में फर्क है।
सर लेकिन
नेगेटिव।
दोनों का लोगो तो एक जैसा ही है, पता कैसे चलेगा कि ये इन्वर्टर, ये वो है, ये वो है?
आपने अगर डायोड का सिंबल देखा हो तो उससे आइडिया
सर
आपको
डायोड
हो
से
जाए।
हम देखें, सेम है।
अच्छा, तो ये डायोड है।
क्या हो गया? जी।
ये सिंबल डायोड का है।
सर डायोड का भी इसी तरीके से उधर के एरो से क्रॉस में होता है।
अच्छा, ये डायोड का सिंबल नहीं है, ये सिंबल SCR का है, ठीक है, सिलिकॉन कंडक्टर रेक्टिफायर का। और ये पॉजिटिव पोलैरिटी होती है और ये नेगेटिव पोलैरिटी होती है। और अगर आप यहाँ देखें तो ये नेगेटिव पोलैरिटी है, ये पॉजिटिव पोलैरिटी है। अब यहाँ जो इन्वर्टर की इससे रिवर्स दिखाई गई, ये इन्वर्टर है यहाँ पे, इसकी ये नेगेटिव पोलैरिटी है और यहाँ पॉजिटिव है, और यहाँ पॉजिटिव है और यहाँ नेगेटिव है। ये एक मेन डिफरेंस है होमोपोलर लिंक के अंदर। बाइपोलर लिंक की अगर बात करते हैं तो इसका जो पॉजिटिव नेगेटिव एंड देन पॉजिटिव नेगेटिव सीरीज टोपोलॉजी में ये कनेक्ट है। अगर आप इन्वर्टर देखें तो ये पॉजिटिव नेगेटिव सीरीज में कनेक्ट है। ये जो
जी
है
जी।
ये रिवर्स ऑर्डर में, ये फर्क है बाइपोलर लिंक और होमोपोलर लिंक
और
में।
होमोपोलर लिंक में, सही
जी
सर।
जी। फर्दर और कोई
सही
डिफिकल्टी
सर।
किसी के जहन में हो तो
नहीं
डिस्कस
नहीं,
कर लीजिए, आई एम
सही सर।
अवेलेबल। और कोई भी सवाल कोई पूछना चाहे तो, वरना हम आगे कंटिन्यू करते हैं।
सर आगे कंटिन्यू करते
Homopolar link has two or more conductors, all having the same polarity, and ground is used as a written path. इसमें use होता है ground as a written path, should be out there. Usually negative polarity with respect to the earth conductors. इसमें earth conductor इस्तेमाल होते हैं, ये जो ground conductor भी कहते हैं इन्हें earth conductor भी कहा जाता है। तो ये रिटर्न पाथ का काम दे रहे होते हैं और नेगेटिव पोलैरिटी का भी काम दे रहे होते हैं। और अब यहाँ देखें तो HVAC सिस्टम जो है इलेक्ट्रिसिटी प्रोड्यूस करते हैं, और यहाँ पे सप्लाई स्टेप अप ट्रांसफार्मर के जरिए दो लिंक के जरिए प्रोवाइड की जाती है। एक जो लिंक यहाँ पे दिया जाता है ये रेक्टिफायर है, जो कि पॉजिटिव टू नेगेटिव और रिटर्न का काम यहाँ पे दे रहा है, लेकिन सप्लाई फर्दर वो ये रिटर्न की सूरत में यहाँ पे जाती है। अच्छा, ये भी एक स्टेप अप ट्रांसफार्मर है जो कि वोल्टेज को हाई कर रहा है, और फिर ये रेक्टिफायर है जो कि उसे कन्वर्ट कर रहा है डीसी के अंदर, और यहाँ से भी रिवर्स पोलैरिटी में सप्लाई दोनों जगह से यहाँ पे गेट हो रही है, और यहाँ से होके ट्रांसमिट हो रही है। ठीक, यहाँ से ट्रांसमिट होगी ग्राउंड टू ग्राउंड। तो ये इसमें एक खासियत होती है रिटर्न पाथ के अंदर। यहाँ की सर्किट कंप्लीट होता है, लेकिन ट्रांसपोर्टेशन जो है नेगेटिव की यहाँ से हो रही होती है, ये नेगेटिव की यहाँ से हो रही होती है, नेगेटिव की यहाँ से हो रही होती है, और आप उसको फिर प्रोवाइड यहाँ से करते हैं फर्दर। अच्छा, जब यहाँ पे आप रिसीव कर लेते हैं अपनी इलेक्ट्रिसिटी डीसी में, देन यू नीड टू कन्वर्ट इनटू from HVDC to HVAC via inverter. You need to convert a three-phase inverter to invert that single two lines positive negative HVDC link to convert by the rectifier of to convert by the inverter of three-phase inverter from DC to AC. After converting of AC, we need to install a transformer which is an step down transformer, which step down the voltages and step up the current. And we got to connect a link of AC system should be out there. So इस तरीके से HVDC में ट्रांसपोर्टेशन हो पाती है। और यहाँ तक जो कॉन्सेप्ट है वो HVDC ट्रांसमिशन लाइन का है, जिसमें इलेक्ट्रिसिटी आपकी ट्रांसमिट हो पाती है, और वर्ल्ड वाइड लेवल पे 1954 से ये सिस्टम चल रहा है। और बेसिकली हम अब इसलिए HVDC ट्रांसमिशन लाइन के ऊपर आ रहे हैं क्योंकि ये तकरीबन लॉसलेस लाइन है, इनमें वोल्टेज रेगुलेशन नहीं होते हैं, इनमें जो कोरोना इफेक्ट, एडी करंट लॉस, और जो स्किन इफेक्ट, कोरोना इफेक्ट, और हिस्टेरिसिस इफेक्ट और दीगर किस्म के फ्रिक्वेंसी ओरिएंटेड लॉसेस जो होते हैं वो नहीं होते, जिनकी वजह से ये जो लाइन होती है आपकी तकरीबन लॉसलेस लाइन है। और ये आपकी बनिस्बत एसी ट्रांसमिशन सिस्टम के सस्ते भी पड़ती है, क्योंकि इसमें आपको सिर्फ दो कंडक्टर इस्तेमाल करने हैं, जबकि HVAC ट्रांसमिशन लाइन में आपको तीन कंडक्टर पर सर्किट इस्तेमाल करने होते हैं, और इसमें डीसी में इस्तेमाल करने होते हैं पर सर्किट टू कंडक्टर्स पॉजिटिव नेगेटिव, एंड HVAC में L1 L2 L3। ये बेसिक कॉन्सेप्ट है जो HVAC और HVDC ट्रांसमिशन लाइन ऑफ सिस्टम में फर्क पैदा करता है, फर्क बताता है। तो यहाँ तक जो सिस्टम है, अब इनके एडवांटेजेस और डिसएडवांटेजेस के ऊपर हम बात करेंगे कि इनमें बेसिक क्या फ़र्क होता है। तो इसे हम नेक्स्ट सेशन से स्टार्ट करते हैं, और यहाँ तक कोई डिफ़िकल्टी हो तो डिस्कस कर लीजिए, पूछ लीजिए। तो सेम लिंक के ज़रिए से ही हम सेशन को दोबारा से ज्वाइन करेंगे, and hopefully all the things being clear up till now in your mind, we again further continue the session. Hello, walaikum salam.